This video is directly focused on providing a training workflow created and demonstrated in the Digital Proving Grounds. This Siemens module automates programming of a CMM using a model-based definition part. My colleagues here at CCAT will now take you through this workflow. Let's check it out.
Hi, I'm Nasir Mannan, Principal Engineer here at the Connecticut Center for Advanced Technology. Joining me today, my colleague Chris Miller, who's an expert at CMM Programming, is going to be showing us the steps that are involved in setting up the strategies within Siemens to be able to automatically program your CMM. We're going to be doing this in the Digital Proving Grounds for the Army. The first step is to log into the Digital Proving Grounds into the virtual machine so that you have access to the Siemens environment. From there, we're going to show step by step how to set up the strategies to be able to consume model-based definition so that your CMM programmer only has to click a button to be able to generate an entire CMM program and then to execute that CMM program on the machine. Chris is going to walk us through the steps to set up the strategies in the Digital Proving Grounds. Chris?
Thanks, Nasir. So today we have NX open. I have a representative part that you would find on an M2 machine gun. We have some PMI established that is associated to some of the features that we want to have measured and inspected. We can see a face here that has an angle call out to this interface here, some holes that have some dimensions. The one thing I want to point out in this here is I have two series of 6 holes, one side that has a more loose tolerance and one that has more of a tight tolerance. So we can see the range of +10, -25 on this side to the left. On the right side, it's plus or minus 1,000s. That's important. We're going to go over that when we start to create the strategies for these holes, so we can inspect them the way they need to be inspected to meet their future assembly requirements.
So for example, if I was to program this manually and I saw that in a 2D print, the tighter tolerance, I would use a different strategy.
Exactly.
And that's what we're going to set up in Siemens.
That's right.
Right.
Yep. So with that being said, I'm going to go ahead and jump into the inspection environment. So File, New. For this, I'm going to go ahead and just click the DMIS General Setup, and I will import my equipment later on. So I'm going to make sure my name and path is all correct. That looks good to me. I'll click OK here. And great, now we're inside the inspection environment.
Great, and the reason we chose DMIS was because we're going to be programming off of a DMIS-based controller.
That's right.
Okay.
So I'm going to go ahead and set up my equipment. There's 3 buttons here I would like to make you aware of. There's the program order view, there's the machine view, and then there's the method view. To set up my machine, I need to be inside the machine view. First thing I want to do is double click on generic machine. Opens up this dialog box. I will go ahead and select my equipment. So I'm going to go into the CMM option, and I'm going to choose the DEA Global Extra. From there, I'm going to want to mount my part onto the CMM itself. This, I'm going to do position part onto machine and set it up as it will be established or set up on your CMM. So I'm going to raise this up some. Just go ahead and angle that to 90 degrees, and the part is facing us on the CMM and rotated this way. Now in the inspection environment, your assembly strategies work the same way. Yep. So if I wanted to, I could go ahead and import a fixture as well, depending on your setup. For this example, I'm just going to have it floating in space, but that's representing the fixture that it'll be sitting on. Yep. So I'll go ahead and drag that up some, and I'm happy with that, so I'll click OK. We have a dialog that comes up just letting me know that everything has been imported properly, so I can go ahead and close out of that. The next thing I want to do is to retrieve the CMM head from the device option from library. So I'm going to expand that menu, choose head, and I will choose the Renishaw PH10M. Next, I need to choose the probe that will be mounted onto the head. Going to choose the millimeter option, and I will opt for this Renishaw probe here. So now that we have that loaded, I'm going to go ahead and expand my Z-slide just so we could visualize the head with the probe attached to the CMM. So if I zoom in here, we can see the head and the probe are now mounted to the machine. So once we have that done and the machine has been set up, the next thing we want to do is link to PMI. That's generally the first step you always take. Okay. This takes the associated features of the part along with kinematic information that the model has embedded within the model and will allow it to create that routine automatically. So this right here is the core to your time savings.
Oh, great. Okay, so that's the key function there that actually enables you to consume or use that model-based definition that's on that CAD model.
That's right.
Oh, great.
Yep. So when I go ahead and allow NX to create those paths automatically, it's going to use its generic methods. And then from there, that's where we'll go ahead and create our methods that will specify for those tighter tolerance features.
I see.
We can assign them to that method, and then we can continue with programming.
Great. Okay, so now because we have the feature recognition in the CMM module, and now attached to it, we have the PMI. When you set up a strategy for a specific tolerance range, because it knows the PMI, it can now apply that strategy.
That's right. So I will go ahead and click yes for this or OK. Takes a few moments, but we have a dialog that comes up and lets us know that all the features were imported successfully. There may be a situation where you have some that import successfully but not linked, or some that don't import at all. That's just an application of your PMI. That's just the time for you to review with your design team and just readdress those PMI concerns. But once you have this window that's saying everything's successful, so I'm going to just expand our program order view here, open up the CMM inspection, and we can now see that we have some features that have been recognized. Along with that, we have some inspection paths that have been assigned to those features, as well as the tolerances. So moving into the method view, I can now see which methods have already been generated and where those features have been assigned to. The ones that I want to focus on today, because we have those two sides, the side that has the tighter tolerance holes and the side that has the looser tolerance holes, this will be the main area where I'm going to go ahead and organize that. So now to create that method, I need to enter into the method dialog box here where you create your method and select the appropriate method type. So in this case, because I know I want to have a new class for the cylinders, I'm going to create a new one for cylinders. One thing I like to do is I like to assign that to the method just to keep things well organized in the tree to the left there. And I would like to name it, let's say, tight tol. And click OK. So now in this window right here, I have a pretty lengthy window where I can go ahead and customize how that method will be applied to those features during the inspection process.
I see. So this is really the window that allows you to set up the strategy.
That's right.
Given the tolerance range.
That's right. Normally with the cylinders, NX defaults to a touch probe method. So typically I think it's 3 rows and 3 hits per row.
Okay.
For this case, because I want to inspect and make sure that we have a really well defined inspection, I'm going to switch this instead of a point set. I'm going to opt for a scan helix. And effectively what that does is an adaptive scan. So it means a continuous scan. It makes contact with the ID of the cylinder, and it continues through a helical path all the way through until you've collected enough data points.
A lot more data points. Yep.
So I'm switching over to scan helix. I'm going to leave the rest of here pretty generic, but there's a plethora of options here for you to actually gather the information that you're looking for. So click OK, and we can see down here that we have this new method created. So if I zoom into my part sum just to find out how NX has assigned the naming to these holes, so now we remember from the model that the tighter tolerance holes were on the right-hand side and the looser tolerance holes were on the left-hand side. So I need to gather cylinders 2 through 7, and I need to cut them and paste inside my new method. Along with that, I also have to gather or collect the paths and do the same thing. So I'm going to go ahead and cut those, and I will paste inside my method. So good. Now we have the two sides segregated in different methods, one being a tighter tolerance method, the one being more loose. This will, again, will just collect a series of points, 6 points total, whereas this method down here will collect as many points as it takes to meet the path of that scan helix. Okay, great. Now that we have our methods defined and we have categorized our geometries and features into those appropriate methods, the next thing we want to do is to resequence the paths. Okay. Effectively, what that's going to do is just optimize based on the options you select, the user selects, on how that programming will be output. Okay. So we've already linked to PMI, it has generated a path already, but not in the most optimal way. I see. That's based on how the methods have been defined. So now we're going to further that optimization.
Okay, so it could take more time, but with the optimization, it'll decrease the time to actually do the inspection.
Right. So initially with the link to PMI, with one extra function being the collision avoidance, you could run through that process and have a fully vetted CMM program. Okay. This just allows for that extra time saving. So if you have multiple parts or if you have a really tight schedule, this will show you some benefits on how to be able to inspect parts faster, meaning that you can get the next part on the table for inspection.
Less time on the machine is great.
Exactly. So I'm going to go to the program order view. I'm just going to point out our inspection paths here. As you can see, we have cylinders 1 through 12. Right now it's in a sequential order. So when I go through this resequence path option or functionality, you're going to see that reorder. So I will open that menu. Here's the dialog asking how do we want to optimize or resequence these path options. For this example, I'm going to choose head angle changes and distance of path. I'm going to not select tool change because I know it's only going to use one probe, but typically if you had multiple probes being used, maybe you want one to inspect all the features it's going to inspect first, be swapped out for another probe, and then that one will run through all of its inspection instead of having to go back and forth between the tool changer. So I will click OK. This takes a few seconds, and as you can see, it has already reorganized that inspection path. Great. Now that we have our inspection paths defined, we resequence them. The next thing we want to do is to run through the collision avoidance functionality. So we can open that dialog with this button here, and we effectively have two different options that we want to consider. We can specify a safety plane. which I will go ahead and do. By specifying a safety plane, this allows us to be reassured that the probe angle won't change unless it's above that safety plane.
I see.
So that's going to completely avoid any collisions or damage. This is something where I'm going to probably put at 2 inches, but a typical workflow might be able to work with something less than that.
Okay.
And the benefits of just working with a smaller safety plane is just a little bit of time savings.
Yep.
But for this example, I will stick to something like 2 inches. I have to enter entire assembly. I will choose this top plane here, and I will raise it, like I mentioned, a couple inches. Great. Okay, so I have 2 inches selected. I'm going to click OK. And then I have a clearance distance. This clearance distance is in inches, as that was the option I chose when I set up the inspection environment.
Okay.
This will have a 0.5 inch clearance in between inspected features.
Okay.
So as long as the probe head doesn't change, it's going to maintain 0.5 inches away from the part before it reaches to the next feature.
So it's kind of a volume around the entire part.
That's right. I'm going to go ahead and click OK. It takes a few minutes for NX to do analysis, but it outputs a report like this that shows us where some move points were entered, some transition points, and potential collisions that still exist.
I see.
So for now, I will go ahead and click out of that menu. I want to generate all the paths and verify the program. So this is going to go through and just make sure there's no syntax errors or things of the nature, just further assuring that our program is complete. So now that we have the part imported into the inspection environment, we have linked to PMI, which created a generic profile, CMM inspection profile.
Yep.
We have customized it and said we want to resequence the paths based on our options that we selected, and then we also have applied some collision avoidance parameters. So we know that we're now creating a safe routine for the inspector to inspect the part with. I can go ahead and simulate that in this environment by clicking Simulate Machine. I get another window that pops open, and I will want to also go into the settings just to check for collision. So if there were some movements or transition points that were created but could not be resolved to avoid a collision, we'll be able to see them here.
Okay, great.
And that's just effectively going to help us know what we need to do to make this process safe, because there might be some boundaries within how it's configured already that cannot be avoided, such as maybe the position of the part.
Yeah.
Right. If the position of the part's too low to the granite table, the probe head angle will swing into the table trying to inspect a part underneath, and we don't want that.
Yeah.
So the last thing for me to do is run the simulation. So I will go ahead and press play. I will zoom out some. We can see the probe head angle changing, and it will start to approach the part. We'll go ahead and move this window out the way. As we see, the sequencing that had occurred, it started at the top hole and it worked its way all the way down to the bottom.
Yep.
It rotated around the part and now it went from the bottom up. So we can see how that resequence path saved us a lot of time from having to organize the order and letting NX make those optimizations.
Yep.
All of this has been done with applying PMI at the design site. So my job as a programmer, I receive the file, a CAD file that has PMI properly applied.
Yep.
I import it and follow the steps that we've been talking about.
Now, once you have those strategies set up, we can just reapply them next time.
Absolutely, yes.
So we're looking at the time it takes to set up the strategies, but then to actually take benefit of that the next time around.
Just reapply them, right? Okay. So it's easy as exporting this as a template.
Yep.
You can import that template into your next component or your next environment. And now that that's already been well defined, all I need to do is just drag and drop the features that I want from one method to another method.
Great. So here we're talking about a CMM programmer who would set up these strategies, but in practice, a person that receives the part to actually inspect on the CMM would really just reapply it and see those benefits right away.
That's right. And it doesn't end there too. If perhaps you have an environment or workshop where you have some very complicated parts and there's very unique ways to inspect that part, you as a manufacturer can enable your more experienced programmers to define these strategies that can then be shared with a less experienced programmer that's utilizing the tribal knowledge, lessons learned, but applying those to the features that need to still be inspected. So it doesn't require all that to be created from scratch. So both on the inspection side and on the future programming side, you really do reap that benefit.
Oh, great. So it essentially becomes like a knowledge base.
Exactly.
To reapply the best practices over and over and over again once you have those strategies.
That's right.
Recorded.
And the other thing too is some manufacturers want their engineers to program things in a very particular way. They don't want there to be that customization. So if you create that locked template and you pass it off to your programmers, you know the part's going to be inspected the way it's intended to be inspected every time. Now that we've run through the simulation, I didn't recognize any collisions. Typically, you'll see something stop and it'll give us a dialogue saying, hey, a collision occurred here. You'll see some things highlighted in orange saying that that's where the collision occurred, but we ran through all the practices properly, apply the functionality that NX offers. And really the last thing for us to do is post-process, push it off to our machine and perform the inspection.
Great.
How we can do that is by going into the post-process option right here, a dialog opens up, allowing us to choose which type of post-processor we want to choose. In this particular case, I'm going to choose DMIS 3.0. I'll make sure my output file is all correct and all the settings that I want to have defined are defined properly, and click OK. Here we have an outputted file showing us the CMM program profile, and this is something that I can either bring over to the machine physically or tie into our network and be allowed to pass on the program to the CMM.
Perfect. That was relatively simple to do, and this was going through the steps of actually setting up the strategies. Thank you so much for walking us through how to set up Siemens to be able to automatically program our CMM. With that, you can really see the value in being able to leverage model-based definition to automatically program your CMM. It doesn't take much to set up the strategies, and now a technician can just simply file, import a model-based data type, click a few buttons, and generate an entire CMM program. This saves a lot of time and has an immediate impact on your manufacturing processes. On behalf of CCAT, I'm Nasir Mannan. Thanks for joining.